Good morning, everyone. Have you ever wondered what makes everything around us? Today, we are breaking down the atomic structure from protons and electrons to the mysteries of the nucleus. Let's explore the building blocks of the universe. Are you all excited? Let's get started. So, before getting into atomic structure, what do you know about atoms? Atoms are unique fingerprints. So each atom has its own identity. So by knowing the atomic number and mass number is the key in unlocking its identity. So atomic number is nothing but imagine it is a person's name, and mass number is her weight. Um, Imagine that a person name is Luna and her weight is 50 kgs. Now, the person named Luna won't be changed, but her weight may change. So that's the difference between atomic number and mass number. Now, how can you define an atom? So we can, as we all know, atom is the smallest unit of matter. So it is made up of protons, neutrons, and electrons. Now, let's get into the atomic structure. So, atomic structure is nothing but the arrangement of atoms, nucleus, and electrons that orbiting around it. Now, let's see the historical development of atomic theory. First came Democritus in 460 to 370 BC. So he proposed that matter is composed of indivisible particles, and he named it as atomos. Atomos means unbreakable or uncuttable. And then came Aristotle. So he said that he rejected that Democritus model, but and he believed that matter was made up of four elements: earth, water, air, and fire. So through these elements only, everything around us is combined. So according to his idea, and this idea was dominated for centuries. And then came John Dalton in 1803. So he said that each atoms are unique and they are combined in certain specific ratios to form compounds. And then came J.J. Thomson in 1897. So he discovered electron through plum pudding model. So his plum pudding model, through this he discovered electrons. It is nothing but he described that he described electrons as in the positively charged soup the electrons are floated. So instead of vegetables, so he just discovered electrons through a plum pudding model. He described it. And then came Rutherford in 1911. So he discovered nucleus through gold foil experiment. So in this experiment, he first fired the alpha particles through the thin gold foil and observed the deflections. And through that deflection, he saw a small, dense, positively charged core, and he named it as nucleus. And then came Sir James Chadwick, who is the student of Rutherford, discovered neutrons and which present inside the nucleus. Now, have you ever wondered how could something so small like the nucleus control the entire atom? Well, the answer is here. So the positive charge of protons attracts the negative charged electrons and keeping them in orbit around the nucleus. So this is the science behind that. And one more additional factor that we all know, nucleus comprises of protons and neutrons. Do you know what is the force that act between them? And the force is Yukawa. This is one more fact. And then came Neil Bohr in 1930. So he said that electrons are in specific orbits or energy levels. And he also said that electrons can jump between levels by absorbing or emitting energy. As we have seen in our school days, it emits protons. That's it. Now, have you ever wondered that every color we see around us is a result of quantum jumps in electrons? Yes, of course, which was the groundbreaking concept in the classical physics, um, which challenges classical physics. Now, then came Schrodinger in 1926. So he says that atoms are not just particles that which are moving in a specific orbitals. So he described the electrons as a wave of probability. So Schrodinger, he said that electrons are not particles; they are just waves of probability. And then came Heisenberg in 1927. So we all are well versed in his principle, uncertainty principle. What's that? We cannot simultaneously measure both the position and momentum of the particle. So that's his famous principle. Now, then came de Broglie. So he was the one who proposed duality. It is nothing but he said that electrons exhibit both wave-like and particle-like properties. He named it as duality, and which was the heart of the quantum mechanics, or which became the heart of the quantum mechanics. Now, as I said before, everything around us, including ourselves, is made of atoms. And that atoms combine to form molecules, and which in turn create cells, tissues, and organs. Now, the main elements which are inside the human bodies are oxygen, carbon, nitrogen, and hydrogen. So they are making up water, proteins, DNA, and other essential compounds that allow our body to function properly. Now, so these are some of the applications and future scope of atomic research. The first is in quantum computing. Undoubtedly, it is going to be a next revolution in computing. And next, in the field of nanotechnology, it is going to create breakthroughs in medicine, energies, and in material sciences. So, let's just recall things. So far, we have discussed about what is an atom, how it is made of, and what is an atomic structure. And we have seen now, just now, we have discussed its historical development of atomic theory. So first, Democritus, he said he described or he named the term atomos, means unbreakable or uncuttable. And then came Aristotle. He said that everything around us it is made up of four elements. And then came John Dalton. He said that each atom is unique and it is combined in a specific ratio to form compounds. Then came J.J. Thomson. He discovered electrons. Then Rutherford. He discovered nucleus. Then James Chadwick, who is the student of Rutherford, discovered discovered neutrons, which presents inside the nucleus. And then came Niels Bohr. He said that electrons moves in a specific orbits. And then came Schrodinger. He said that electrons are not just particles; they are a waves of probability. Then came Heisenberg. So he proposed an uncertainty principle, means we cannot simultaneously measure both the position and momentum of an electron. Then came de Broglie, and he proposed duality, means which is nothing but electrons have both the particle-like and wave-like behavior, and he named it as duality, and which has become the heart of the quantum mechanics. And then we have discussed its application. It is going to create a revolution in computing, quantum computing, and in the field of nanotechnology, it is going to create a breakthroughs in medicine, energy, and in material sciences. So these are some of the brief notes of historical development of atomic theory. Thank you.